I know that with the equations, I'm being very particular on how I want it done. I promise you that as you get older, you will understand why I made you do it this way. Okay. And so I am going to be very inflexible on like I'm going to want it a certain way, absolutely 100% of the time. Okay. And that's not going to change the rest of the year. That means on the quiz on Friday, if you don't show the steps, I mean, I haven't decided if I'm going to just give you a zero and make you do it again, or like just take off half the points, which will basically mean that you fail if you don't show the work correctly, basically. So you've got to do it the right way. All right. Um, Everybody except for I would say I've seen two people who've turned in work the last couple of days who I've not seen. One person did it wrong, then has corrected it on the next day, needs to go back and correct it the first day. Um, and then two people turned in not showing the work properly on either of the first 2 days, and you need to fix this. I just put 0 points in and said redo it. Use the video going over it. It's not so much that you couldn't figure out the answers in your head, it's that you got to know how to show them. Okay. All right. So getting moving here. All right. So I think most of y'all know these things at this point. I do make sure you know that there's a video going over all the work I've assigned, which is super important, especially on a week like this where the showing of the steps is the process is so important. Okay. Make sure you're checking over your grade book, see anything that I'm posting in there and comments and so forth. If you need to redo things. Um, yeah. Now, do be aware that all Q3 work is due this Sunday night, and it will be closed after that. Um, so you got to be looking over that, see what you're missing, see what you need to redo before that time. Um, now, the quiz for this week, I'm actually putting on the fourth quarter, all right, the one that we're taking this Friday. The reason I'm doing that is so that if for some reason it doesn't go well for you, that you have a chance to redo it. And then your unit test could be used to bring that up too if we need to do it that way. So yeah. Um, all right. Now everybody should be logged on to Nearpod at this point. All right. Let's see. Gray, did you just get that link? Did it show up for you? Okay, good. All right. Now, so we're still on the solving of the one-step equations here. I could show you a bunch of different standards of how I'm mixing it together, but that would bore you to tears. So I'm not going to show you. You just got to trust that I know what I'm talking about. Okay, in the sense that we're doing the decimals and the fractions too. All right. So today we're going to use inverse operations to solve one-step equations with variables. And then we're going to check our work by substituting the answer back in. And we're going to do it with rational numbers, meaning fractions and decimals. Okay, so what we're going to be doing is today for your practice on this is going to be with decimals. Tomorrow is going to be with fractions. Okay, and then Friday's quiz will use all of the above. All right. Okay, so today the steps are this will actually be probably on um the shorter end of my lessons, so I might actually finish by 10:45 today. All right. Because none of this is going to be new stepwise. I'm just going to be reminding you of some decimal rules as we go. Okay, so here's what it needs to look like. All right, I don't think you have a draw on it on this one. Okay, so we're trying to get x by itself by doing inverse operations. So the opposite of minus 2.25 is plus 2.25. Okay. Then what we do on one side, we do on the other side. Okay. Now, one of the things we got to remember here, all right, when we're looking at our decimal operations is what's the rule for adding and subtracting decimals? Okay. So here you line up the decimals. So if you don't see one, it's after the number. So x equals 17.25. Okay. And then you would check that by doing 17.25 minus 2.25 all right, which equals 15. All right. And then 15 equals 15. All right. You could probably see that one just by looking at it. All right. So that's the first one. Okay. Then second one, I know I'm like kind of being, some of y'all are like, dude, I get it. Let's just go. All right. Yeah, I get it, but whatever. Get X by itself. Notice the X is on the other side, but the number on the side with the X is the one we got to get rid of to isolate the variable. Okay. Now I think we can probably still do this right here. I don't think it should be a big problem, but the decimal and the zeros, that's too much for you, like right there. Then go to the side and do it. But I think we can probably handle that. Bring the decimal straight down. And so that gives us X equals 15.75. Notice that I am unit for thinking questions. Lorraine, I'll get your unit 4 questions graded today for sure. All right, so notice that I kept the X on the same side. I'm not just flipping it around, like leave it like it is. Okay. So then we go 12 equals 15.75 minus 3.75. And again, I made these pretty simple. So the check step here, we're probably good just to put 12 equals 12 there. I did notice somebody yesterday who put one in there and it was equal, but it wasn't. Not to be embarrassing, I'm not gonna say the person's name because it's a good student, but they put down 14 times 5 equals 65. But no, it doesn't, because 14 times 5 equals 70. That was on one of the practice ones yesterday. So you got to make sure that what you got actually does equal. Otherwise, that's rather silly. Okay. Okay. Now let's go to the next part and should be ready for you to do a couple. It is. Okay. So same steps as Monday, just different types of numbers. Okay. So now you do these two. Okay. So first thing you should be doing, drawing the line down the equal sign. Okay. Oh, I should do that with the, I have it where I can add a date. All right. So you should be going on these first two. Give you a minute or so to get that. And again, I made these first couple, the decimal part of this is not that hard. Okay. Gina, yeah, yours is glitching because I'm on slide 10. You might want to log out and log back on of your Zoom, or I don't know. I'm not sure. Okay, let's see how it's coming here. All right, so I don't know. Potentially, a couple of y'all are having a hard time with the steps here. Give it just a second for people who are not having a hard time with it. Okay, so here's the way the steps need to look. Okay, and when I'm looking at your Nearpod, like I'll look at it tomorrow morning, and if yours doesn't look like mine, you're not getting credit. Okay, so here we go. So the opposite of minus 5.7 is plus 5.7. Okay, so if yours didn't look like this, make it look like this. What you do to one side, you do to the other side. Okay, so plus 5.7. Okay, now we line up the decimals when we add. That makes that 19.0. Okay, so minus these two right here are additive inverses, so that makes 0. Okay, then the equal sign should be right on that little line, and then that gives us 24.7. Okay, so make yours look like that. And if you weren't here the other day for some reason, understand that I am going to be extremely extremely strict on it looking just like that. Okay. So if it doesn't look just like that on the practice this week, I'm going to send it back and say, do it again. All right. And all the good math teachers I know do it are the same way on equations. All right. So here's the first one. So there's the check stuff there that is required on these. All right. So give you a second on that one. Then hopefully you're ready to do the second one by yourself. Okay. This is the way it needs to look. Yeah, question mark is not acceptable here. Okay, like get to work on it. All right, so I'm gonna start jumping in and making some comments on people's here and what it needs to look like. So this right here, there, there, all right, right there. Okay, like this. All right, see it? All right, so that's what it needs to look like. Okay. All right, so this one, let's see, that looks good there. The two is kind of hidden there, but I see what's going on. All right, that's good. Plus, plus, good, good. All right. Okay. All right. So on the second one here, all right. So we got a plus. Let me change colors so y'all can tell we're on a different problem. Plus 2.98 here. So notice it's on, we got to get rid of the number on the side with the X. It's no different than the other day. Just now we're operating with decimals, 2.98. Okay. Now, you probably need to do 32 plus 2.98 over here somewhere. All right. Okay, so then bring the decimal straight down, 9.8, and then 34. Okay, so the silly eraser thing. There we go. All right, so now I did it again. It's on my nerves. It's like when you get to the edge of the screen, it likes to drag all over the place. All right, so now we got 34.98 equals X. Okay, 34.98 equals X. Okay, then your check step is 32. So we're substituting back in. Put the 34.98 in for X. 34.98 minus 2.98. And then 32 equals 32. Okay. All right. Give you a little bit to get that one looking accurate. Okay. Looking like it's supposed to. So, okay, some of y'all are not showing it properly, all right? And maybe you think you are. This is good right here. I'm good with that. Okay. Um, like I don't think I could be much more clear than it needs to look basically exactly the same way. So like this is good. Okay, right here we're like, not enough room there. I'm gonna come down here and do it. So this is good right there. Perfect. That works. All right. But like over here, I'm not trying to call out anybody in particular. I don't know whose slide it is, but that's not the actual problem, like the way you do the steps here. Okay. All right. So like this is the actual steps. This person has got to finish their check step. Again, if you weren't here the other day, I talked to Miss Ellenberg, who teaches 8th grade, Miss Butler, who teaches 7th grade, Mr. Counterman, who teaches Algebra 1, and they all agree with me that me making sure that you show these steps the way I'm saying it is the right way to do it. Okay, I'm not making that up. Promise you, this is a math process that you need to do. Okay. All right. So again, I'm going to show you mine one more second here. Okay. So you should have plus 2.98 on either side. That gets rid of this. That leaves you with x equals 34.98. Just like over here, we did plus 5.7 on both sides. You do the same thing on both sides to get the x by itself, right? So you do inverse operations to isolate the variable. What you do to one side, you do to the other side, and then you check your work. Okay? Okay. Now, next one. All right. So addition. All right. So addition. Now I'm going to do this one. Okay. So this one's going to be minus 7.8 on both sides. Okay. Minus 7.8. All right. So those cancel out. All right. Going to give you a 0. So it leaves you with just x over here, isolated the variable. Okay. Then this is 12 minus 8 is 4. All right. Then that's 2. So it's 12.4. Okay. Yeah. This one's not a draw on slide. This one's the me giving you an example, and then the next one you draw. All right, so 12.4 plus 7.8 equals, all right. Oh, yeah, that's 8. My bad, Lorraine. I would have caught that in just a second there. Good catch. All right, equals 19.2. And that's when you looked at that, you're like, wait a second, that doesn't make sense because once you carry that 1, that won't work. Because 11.4 plus 7.8, okay, it does write a little better for me on this than it does on the little fat crayon thing, but still a little messy. 19.2 equals 19.2. I know, but okay, so that one's good there. All right. Any questions on that one? I'm just going to go. The only thing I need to show you on this other one right here is just how the first part looks. I don't necessarily need to go all the way through the check step on this one. Okay. So watch just right here. So if this is plus 5.87, then what we need to do here is minus 5.87. Like this. I was just showing you them in a different order. Okay, so then this is x equals, and then we do the minus 5.87. You line up the decimal, meaning it's after the 0. Okay. All right, so we got 6, we got 10, and that's gonna be 9. Okay, 3, 1, decimal straight down, 1, and 4. Okay, and then we would check that. But I wanted you to see how this is the, plus, so we're doing the opposite, which is minus to get rid of it. Okay. All right, now let's go to the next one here. And there should be a couple for you to work on, or at least one. All right. Next one. All right. Okay, so now you got 2 to do. So you should be starting with drawing your equal sign. Okay. Then you say, okay, got to get x by itself. So what do I got to do? What I do on this side, I do on that side. Okay, see if we're getting on the right track now. All right, this person right here, totally on the right track. Okay. I've got somebody's already done with the entire first one here. Okay, so what you should be doing right now is doing minus 12.5 on both sides, right? That's where we should be. So minus 12.5 over here. That is nice because it's not as fat, Chloe, but it's also hard to see. There we go. Minus 12.5 over here. You just line up the decimal. So that's gone. All right. Plus 12.5 minus 12.5 equals 0. All right. Now we subtract here. That's going to make this 6. That's an 8 now. So that's a 6. Okay. So that's 16.6. Okay. Now we're going to check it. We got 16.6 plus 12.5. And that equals 29.1. So 16 and 12 is 28. 0.6 plus 0.5 is 1.1. So that does mean that's going to be 29.1. All right. Okay. Any questions on that first one there? Okay. Let's get on the second one. See how you're doing with that. I also pointed out on this slide that you could use commutative property for addition and multiplication. Therefore, you could just say, you know what? I don't want this one in this order. I could just make it x plus 8.74 because I'm more comfortable with that. Okay, do it. I don't care. Okay, just as long as you show the steps once you do that. All right, see how it's going here. Okay, so on this one, you should be subtracting 8.74 from both sides, right? From both sides of the line. And then make sure you line up your decimal. So the decimal's after the 16. Decimals after the 16. And okay. All right, I'm gonna start going over it just in the interest of time. So make sure you're keeping up with me here. Okay, so now I'm gonna subtract the 8.74 from both sides because that's gonna get x by itself. 8.74. That gets x by itself. Okay. So minus 8.74 over here also. Okay, like so. All right. So that gives me x equals right here. Okay, then we'll have to borrow. Yay. I know you're thrilled with that. Okay, so this 10 minus 4 is 6. 9 minus 7 is 2. And then 15 minus 8 is 7. So 7.26. Drawing on Nearpods. No fun. All right. And then 8.74 plus 7.26 equals 16. And 16 equals 16. All right. Any questions on this one? Okay, give you a few seconds to finish that up. Okay. If you're telling me you're confused, but you're not writing what I'm doing on there, that doesn't make a lot of sense. Because a lot of doing the equations is just following through with the steps. And the more you see it, the more it will start to make sense. Okay. That's just literally how this skill works. Okay. All right. Okay. We'll move on in about 5, 4, 3, 2, and 1. Okay. I was wrong. It is going to take not not a little time. It's going to take more than I thought. All right. So I didn't put 2 different slides on this one. Okay. So we're going to do kind of do these 2 together. All right. So these I just, because it's hard to type this on here like this. This question is x divided by 2.2. Okay. So you just do it with me here. Equals 8. Okay. Now, here's something I want to point out to you. You could put this over 1 right here and then just divide by 2.2. That's what we're going to be doing anyway, honestly. Okay. So here's what I'm saying. Just watch for 1 second. Okay. What I do in orange, just watch. So what I'm saying is when we did equivalent ratios, right, or unit rates, you could have divided by 2.2 here, right? So then this is divided by 2.2. And then the inverse or the opposite would be to multiply by 2.2. 1 times 2.2 is 2.2. 8 times 2.2 is the answer. We're doing precisely the same thing. It's just that we're showing it a different way right now. And now if you get to a quiz or a test and you're like, I'd rather show it the other way. I get that way. That's cool. All right, that works. Okay, because that's a perfectly legitimate way of showing work on this question. Okay, so I'm gonna get rid of the orange part. So the part I'm doing in the dark bluish, that's what I want you to write. Okay, now, so this means divided by 2.2. Okay, the opposite of divided by 2.2 is times 2.2. Okay, you could go ahead and put that over 1 because then it's like multiplying fractions. So this is 2.2x divided by 2.2. All right, or you can just say I'm going to divide this by 2.2 and that's 1. Divide that by 2.2 and that is 1. Okay, alternately, that would be 2.2 times x divided by 2.2, which just gives you, let me bring my equal sign down, x equals. Now, what we did on this side, we got to do on this side. So we're going to do times 2.2. Okay, so 8 times 2.2 is 17.6. Okay, I'm doing that in my head here because I don't want to take forever today. Okay, so that would be 2.2 times 8. Remember, there's 1 decimal place in the problem, so 1 in the answer. Then we would say, okay, to check this, 17.6 divided by 2.2. All right, and that does equal 8. Okay, so 8 equals 8. That's cool. All right, I would just check that, frankly, by making sure like that I actually multiplied that right, because that's what you're gonna have to do to check that anyway. All right. Now, let's go to the next one. I'm going to give you a few seconds to get a head start on me here. So let's go 14 equals x divided by 0.7. Oh, sorry, 14.2. Thanks, Glenn. 14.2. Good call. Okay, 14.2. Okay. All right. 14.2. All right, then we got x divided by 0.7. So go ahead and you're doing times 0.7 on both sides. Okay. Great, I'll check it right now. We'll see what we got here. All right, so go ahead and get either side times 0.7. Let's see, which way did you do it there? Yeah, you can do it that way. That's not bothering me. I, so I'm not gonna mark it wrong for the times being down below it like that. That's not my preferred way. And then honestly, your seventh and eighth grade people probably are going to be like, no, don't do it that way. So doing it the way that I'm showing you is probably preferred. But I'm not going to mark it wrong for, like, for example, like this times 0.7, like that. I mean, I'm not going to mark that wrong. But I will say that I know people will probably correct that later. Um, all right, so let me fix this one. We do need to get all the way through fractions, so I got to go kind of move here. So then times 0.7 over here, okay? So then those cancel out. I do this times 0.7. All right, so then x equals, all right, interest of time, I don't need to do this one. What's the answer on that one? Well, we get 14. What do I get? 14.2. No, is it 9? See, 9.94. Yeah, it looks like 9.94. All right, so 9.94. All right, is what it looks like it is. All right, so let me put mine on here so y'all can finish it up. Because basically, when we're doing Nearpods, it's like class notes, really, is what it is. Okay, so then we would say, okay, 14.2 equals 9.94 divided by 0.7. Okay, and then that's 14.2. All right. All right. Now, I I have saved what I would say the best for last kind of thing here, where the part that we're about to go over next. Yeah, Lorraine, yours looks good. That's good. All right. Is the part that um the decimal division part, which is like no one's favorite at all. Okay. Um, all right, so I gotta move on. If you got some slides you need to go back and fix, you can go on the student one, student based one, and then just tell me to add in the other slides, okay? All right, so here's what we got here. And now the showing of the steps here is not super hard, okay? So this one's just me. So watch right here. This is times 0.5. The opposite of times 0.5 is divided by 0.5. Okay. What you do to one side, you do to the other side. All right. Now I'm just going to do it through here. I'm not going to write the check step because I'm trying to show you this quickly. So we're going to divide 0.5 into 24. Okay. So I need to remind you of the decimal division rule. You move the decimal to the end on the outside and do the same on the inside, meaning here we moved it one time, so it's going to be 5 into 240. Okay. And 5 into 240 should give us, I think, 48. Okay. We do need to do the check, but I'm just trying to show you the decimal division rule here. Okay. So here we divide both sides by 2.4 because this is times 2.4. Okay. Now we do 2.4 into 72. What we do on the outside, move it one. We do on the inside, move it one. So if it had been 2 or 3 times, we move it the same amount anyway. So then 24 into 720 is going to be 30. Okay, once we divide that out. So that would look like this. Okay. Any questions about what I'm saying besides the fact that I haven't done the check stuff? Okay. I was just reminding you of the decimal division rule on that. All right. So all right, let's go to the next one here and I'll finish erasing. All right. So I should have given you, yeah, I did. I given you some with the decimal division here. And we got to move pretty quickly because we do, like, with the way our schedule works, we have to do fractions, right, today. It's just not going to work for us not to do fractions today. All right, so I'll get started on mine. So you get on yours and then check with mine here. Okay. I'll give you about 10 seconds to get ahead of me. All right, so here we go. I'm going to get going. You can follow with me if you need to. If you're ahead of me, that's great. So this is times 0.5. The opposite is divide by 0.5. So 0.5 divided by 0.5 is 1. Okay, what we did to one side, we do to the other side. So we divide that side by 0.5. We divide this side by 0.5. Okay, 15 divided by 0.5 is going to be 30, but we need to show that. Okay, so you move the decimal to the end on the outside, do the same on the inside. So that's 5 into 150. 5 times 3 is 15, right? So then that makes that 30. Okay, then we check with 0.5 times 30, okay, equals 15. So then half of 30 is 15. So then that one would look like this. Okay, there's the first one. All right. So you need to be showing both sides divided by 0.5. Really, really, really needs to be with the little fraction bar, not the dot dot. Okay, I'm just telling you. All right, like this. Okay, so like on this next one, for example, I'm putting fraction bar. That means divided by 0.12, right? So that number divided by itself is 1. So again, use the fraction bar as your division sign here. That's what's going to, when you do these algebraic equations, it's always going to be the fraction bar that's used for division. Okay, so here now, we're going to do 0.12 into 144. Okay, move the decimal over 2. So that's going to be 12. And we move it 2 on the outside. We move it 2 on the inside. So it's going to be 12 into 14,400. Okay, so that's 12. And then 1,200. Okay. So to check, we got 144 equals 0.12 times 1,200. All right. And then that's going to be 144. So 12 times 12 is 144. The decimal moves it over 2 times. So that is correct. All right. All right. Now, unfortunately, we still have 3 left with fraction slides. Okay. And again, with us having twice a week lessons, we have to get these done today. Okay. Because we have limited amount of time before we even get to like SC ready testing. Okay. So I'm sorry that it takes us a while, but this is literally what we got. All right. Now, fractions. Fractions and equations are going to be the same as other equations. Okay. So we got the little line for the equal sign. Then we do minus 3/4 to get the x by itself. Okay, so that's gone. All right, what we do on one side, we do on the other side. Okay, like this. Now, here, we got to get this over a common denominator. Okay, so 3/4 equals 6/8. Okay, so now we have 7/8 minus 6/8 equals 1/8. All right. So notice here, I took the 3/4 right here. I did it times 2, right? Equivalent fractions. So now I had 7/8 minus 6/8 is 1/8. So then we would check it by doing 3/4 plus 1/8 equals 7/8. And that's 6/8 plus 1/8 equals 7/8. Okay. Again, in interest of time, I'm just going to show you one with this subtraction now. So we got minus 1/2. The opposite is plus 1/2 on both sides. Okay. What we do on one side, we do on the other side. Okay, that leaves us with just x over here. So 2/3 and 1/2. We need a common denominator. That's going to be 6. Okay, so that's times 3. So that's 3/6. This is times 2. So that's going to be 4/6. 4/6 plus 3/6 is 7/6. Okay, which equals 1 and 1/6. Okay, so I would check that with the 7/6 in there. So 7/6 minus 3/6 equals 4/6. That would check it. Okay, so again, it's the same thing. It's just we got fractions now. Okay, that's what we got. All right, now let's do one of those here. Okay, just let's do one together. So you write on this one as I'm writing on it. All right, just in interest of our time here. Okay, so take your equal sign here. We're just going to do the one on the left. Okay, because the other one, we're just going to, it's the same thing. It's just plus. So we're going to do minus 1/2 right here. So you do what I'm doing here. Then what we did on one side, we do on the other side. So minus 1/2. So then x equals, okay, now this is 7/8. That's good already, okay, because it's already got the denominator we need. We need 8ths, okay? So 1/2 is going to be 4/8. So we're subtracting. 7/8 minus 4/8 is 3/8. Okay. So we're doing basically equations and fractions. We're just doing them together. So then we're going to check it. So here's my check. This one's just going with this one. We're not going to do that one right now. Okay. So 1/2, this is a check step, plus 3/8 equals 7/8. Okay. So 1/2 is 4/8. 4/8 plus 3/8 is 7/8. Okay. All right. So get that one down. Maybe tell me what questions you got in the chat if you got a question on that. So we're doing the same thing in the sense that when you're doing it with fractions, you're doing the same step for equations. You just got to know your fraction rules. Same with decimals. Okay, you're doing the same steps just with the rules for decimals. Okay. Questions on that? Okay. Now, with dividing, okay, so with division ones, all right, we got basically what we're going to have here is, and I said already, you can solve these with equivalent ratios. That'll work too. So like this one right here, if it was 5/6 equals x divided by 12, you already know how to solve that, right? That's times 2. So that would be x equals 10. So if you get one like that, then just like that's what that is, okay? So you don't have to solve that a different way, okay? Now you could solve it a different way, all right, which is the way I'm about to show right here, okay, by doing times 12 on both sides. Okay, so here's what this looks like. All right, so x divided by 5 equals 1/4. Okay, now I pointed out here that fraction denominators on here, like over, say, 3/5 or something, that's the 7th grade version of this. Okay, so this means divide by 5. Okay, so here's the trick on this. Okay, so this means divide by 5. The opposite of divide by 5 is times 5. Right? So then those 5s cancel out, leaving you with just x. Okay, so watch this. We did times 5 here, so we do times 5 here. Okay, so 1 times 5 is 5. 5 times top, bottom times bottom. So that equals 5/4. which equals 1 1/4. Okay, so then you would, theoretically, your check here would be 5/4 divided by 5, which equals 1/4. Okay. Everybody see how I got to this answer? That's what I'm wanting to see here. Make sure you see that. So I did times 5 here. So since I did times 5 here, I did times 5 here. Because what we're trying to do is get the x by itself. If you do, this is 5x divided by 5. That's 1x. Okay. All right. Next one. Do one together. Okay. All right. Okay. So now this is the one we're going to do together. Again, in interest of time, we're going to just do it all together as opposed to me waiting on you. Okay, so but your x divided by 12, just rewrite it here, equals 3/5. Okay, give you about 10 seconds to get ahead of me. We still have one more slide of these with the multiplication ones. Okay. All right, so x divided by 12, the opposite of divided by 12 is going to be times 12. Okay, so see, this is divided by 12. So now we need to do times 12. Put any number over 1. Okay, so those cancel out. They're ones. Okay, so what you do on one side times 12, you do on the other side times 12. Okay, now 3 times 12 is 36. Top times top. 5 times 1 is 5. Okay, but the bottom times bottom. Then you divide 5 into 36 here. All right. 5 times 7 is 35. Okay. So then 7 1/5. 7 is the whole number. 1 remainder out of 5. Okay. Okay. Questions on that? So that is how you do the division type. All right. The last one here. If you finish that one up. Again, if you don't think your slides look like what I need them to look like, when I post the lesson video, you can go back and fix it. Okay. Again, the exact, like, making it look right is the big thing on this. Okay. Because when the questions get more complicated, you're going to struggle if you can't get these right. Okay. All right. Now, here's the multiplication ones. Okay. And I just need to, these are the ones people really struggle with. Okay. So watch carefully. 2/3 x equals 3/4. Okay. Now, there are two ways you can do this. This is the most like obvious way, but not the way you're going to want to do it. If this is times 2/3, the opposite is going to be to divide by 2/3. Right? But nobody wants to do that. Okay. So this would be 3/4. So here's how you do this. That's 1, right? So 3/4 divided by 2/3. Okay, then you keep change flip, right? 3/4 times 3/2. Okay, so that's 9/8. Okay, which is 1 1/8. Can you do it that way? Yes. So that's way number one. My guess is most of us don't want to do it that way. Okay, so I'm going to show you the other way that I actually consider to be a shortcut, but is actually mathematically correct too. All right. So the key to this is the fact that any number flipped upside and multiplied by itself is 1. Okay, so here's what I mean. If I take 3/4 and I multiply it by 4/3, I get 12/12, which equals 1, right? Because they all cancel out and it becomes 1. If I go 1/3 and I flip it over times 3/1, it's called the reciprocal. Those cancel out and I get 1. So if I need to get rid of the number next to the x that's times 2/3, the way I get rid of it is by flipping it upside down and multiplying. Okay, watch. This is a good trick. So times 3/2. Okay, so what does that mean? Well, These 3's cancel out. Those are 1. The 2's cancel out. They're 1. So x equals, now what did I do on this side? Times 3/2. Okay, so I do the same on this side. So that's 9/8 or 1 with 1/8 remaining. Okay, now I'm going to show you a couple of other ones here because I want you to see that it works the same regardless of whether you got a whole number or just fractions. Okay, so these are actually easier, but I want you to see what it looks like. So this is divided by 4, right? Okay, so this is just divided by 4 divided by 4. So if it's like that, you could do it this way, or you could do it times 1/4. Okay, so to be consistent with what I was showing you on the last one, you could do like this, times 1/4. Okay, and then those cancel out. Times 1/4, and you get 7/32. Okay, that way works right there. Okay, or you can divide both sides by 4, and then when you divide both sides by 4, you would do 7/8 divided by 4. Sorry, divided by 4, and then you would keep change flip. Okay, now on this last one over here, all right, we would divide both sides by 3/4. Okay, or you don't want to divide both sides by 3/4, which I don't. I'd rather just do it all right here. So I'm going to multiply both sides by 4/3. Why? Because any number flipped over and multiplied by itself becomes 1, right? So that's 12/12, which just equals 1, right? 4's cancel, 3's cancel, okay? What we did to one side, we do to the other side. So we multiplied this side by 4/3. So we multiplied this side by 4/3 also. Put any number over 1. So that's 32/3, which equals 10 2/3. Okay. All right. So that is the fractions with the multiplication. Okay. So let's do one together and then we'll be done. Okay. And again, we have decimals today, fractions tomorrow. Quiz Friday has both decimals, fractions on it, as well as whole numbers. Okay. So got to make sure you get those. If you're not getting them, you really need to come to target time because this is all the time we have to do this. I can't slow down a bunch of weeks. Okay. So do these with me and then we'll be done. Right? So this is 4/5 x. I know that's hard to read. So 4/5 x equals 12. Okay. So now we got to say, all right, we need to get rid of 4/5 times x. So we flip it over and multiply. So you do times 5/4, right? The 5's cancel out, the 4's cancel out. So now I just have x. So it's isolated. So on this side, we multiply times 5/4. So on this side, we multiply times 5/4. That's 60/4. Right? Top times top, bottom times bottom. Or you could simplify before you multiply. And 3 times 5 is just 15. If you did it this way, then you divide 60 by 4 and you get 15. Okay? Okay, now the last one here. Okay, so I have 7/8 equals 2/3 x. Okay, now still works the same way, even though we got the x kind of in the way there, right? So we flip it over and we multiply. Okay, because then this is 6/6, or we can just cancel it out, right? Those are 1's and those are 1's. So we do this side times 3/2 also. Why? Because we did this side times 3/2. Okay, so then that gives us 21/16, which equals 1 and 5/16. All right. So that's the steps on those. Okay. Now, what I'll say is if you're good, as soon as you finish up your slides, you can go. If you got questions, I know that I'm moving fast because with the nature of us being a twice a week lesson school, I had to do all of this today. I know it's a lot. So if you need to stick around for a while and ask questions, we can do that. If you need to come to target time to get me to look through some more questions, we can do that too. If you're good, you can go. Okay. And then just make sure you drop into target time one of the next 2 days if you got questions. Remember also that as you're going through, right, as you're going through the practice, use the videos to make sure you're showing the work properly. Okay. And then if you're still confused, come back and ask. All right. Okay. I'll see you guys later unless you need to stick around and ask some questions. All right.